In lesson 1.4, we're going to look at ways that we can simulate athletic ability. When we talk about a simulation in statistics, we're referring to a controllable event that has the same probability of success as an athlete's or team's presumed ability, and that can be repeated many times. We use simulations because it may be difficult and time consuming to have an athlete repeat an event under identical conditions enough time to do proper analysis. For example, if a baseball player claims that they have the ability to hit a ball 30% of the time, in other words, that their batting average is 300 or .300, the only way that we can test that claim is to have the player take thousands and thousands and thousands of at bats under the exact same conditions and see if he does indeed hit 30% of the time. The problem with this is that as the player hits more and more times, they're going to get tired. And so we no longer have identical conditions. So instead of having the baseball player do that, we would find some way to kind of imitate the thousands and thousands of at bats. Suppose, for example, Mrs. Soto claims to be a 50% free throw shooter, and her statistics class doubts this claim. So she goes out to the court and shoots 10 times, and she only makes 3 of her 10 free throws. This, of course, we would think maybe kind of supports the class's doubts that she is able to be a 50% free throw shooter because 30% or 3 out of 10 is less than what her claim is. But is this far away enough from her claim that we would have good evidence that she's lying about her ability, or could this result just be due to random chance? Now, to analyze this situation, we would want to look at many sets of 10 free throws, not just one set. And if she shoots 10 free throws many times, we know that probably some of the time she would make 5 out of 10 or 50%, which would match her claim. However, if she was a 50% free throw shooter, sometimes she might make more than that. Like maybe she would make 6 or 7. Sometimes she might make fewer. She might make only 4 or 3. But we would want to know at what point would her performance be far enough away from her ability that we would have good evidence that her claim was not true. So at what point would we start to be suspicious about that? Now, in this case, we're going to use a coin to simulate free throws. And the reason we're using a coin is because a coin is 50-50 heads and tails. So the probability that the coin lands showing heads is the same as the probability that she would make a free throw. So if you have a coin at home, what you're going to do is toss your coin 10 times. And we're going to keep track of how many times the tosses land showing heads, as this would represent successfully making a free throw. So you're going to do 10 coin tosses, and those 10 tosses will represent one trial. So let's say, for example, when you take your coin, the first time you toss it, it lands showing heads. So we'll mark that as making a free throw. And then maybe the second toss is tails. And then we have heads, and then tails and tails. And then maybe we get heads and tails and tails. And the last one lands showing heads. So notice in this case, if I count those up, I have 1, 2, 3, 4, 5. And she actually made 50% or 5 out of 10. Now let's suppose that we repeat this and the next time we get something that looks like this. So we have heads, heads, tails, 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 heads, tails, 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 tails. So this time she only made 3 out of 10, which is what happened when she went out to the court. Now on your dot plot, you would record your results. So we had 5 and 3. And so you would put a dot at 5 and a dot at 3. And notice the dot plot goes from 0 to 10 because if she's shooting 10 times, she could make none of the free throws or 1 or 2 or any number of them up to 10. Theoretically, that's possible. Now, if you were in a class, and we're going to assume that you're in a class with 25 total students, everybody would do this twice. And so they would all put their results together on the same dot plot, and we would get something that looks like this. So your results there would be part of the classes, and altogether we would have 50 total dots. You can go ahead and pause the video and copy this dot plot into your notes. Now, notice we did get 5 out of 10 on several of the trials. That's kind of what we expected. And we said if she actually was a 50% free throw shooter, we wouldn't be that surprised if she got 4 out of 10. We also wouldn't be that surprised if she got 6 out of 10. And most of the results are within this range here between 4 and 6. As we go out from that center, we get those results less often. Okay, notice, for example, that only twice she was able to get 8 out of 10, and we didn't end up with any trials in this simulation that got 9 out of 10 or all 10 out of 10. That would be very surprising if she was a 50% free throw shooter. Now, in our case, we want to look at how likely it was that she got 3 out of 10, because 3 out of 10 made us suspicious that she was maybe lying about her ability to actually be a 50% free throw shooter. Now, if 3 out of 10 made us suspicious, certainly 2 out of 10 would make us more suspicious. 1 out of 10 would be really suspicious. And if she was not able to make any free throws out of 10, we would have pretty strong evidence that she was lying about her claim of being a 50% free throw shooter. So basically, anything 3 or below is what we're going to consider evidence when we evaluate her claim. So each dot on the dot plot represents one trial of 10 free throws. And we had 50 total trials completed by the class. Now, based on our simulation, we want to know what is the probability that she would make 3 of her 10 free throws or less if she really could shoot 50%. Again, if we go back there, we want to count up how many dots there were out of our 50 dots total. That will give us an idea of the likelihood of this happening. And if I count up those dots there are 7 in that range. So 7 out of 50 is 14%. And in statistics, 14% is considered likely to happen. Generally, anything 5% or more is considered likely. So we would say that it's likely that she made 3 out of 10 free throws just by random chance, and she really could still be a 50% free throw shooter. So this is probably the case where maybe she just had a bad day. Maybe the pressure of her students watching her made her a little bit nervous. And we can just chalk this up to random chance. We don't really have good evidence that she was lying about her claim. Now, there are other ways to perform simulations. We can also use spinners. And there are lots of types of spinners. Probably the most common one is one that's divided into 4 sections, but you can also make spinners with 3 sections or 8 sections or 10. And you can change the angles in the spinners basically to be any probability that you want. We can use cards. And the key with using cards here is that you have to draw cards with replacement, which means you put the cards back every time. And you can use dice in some situations. You want to use methods that produce independent trials, which means the probability of success is the same on every trial. And that's why with cards, we have to put the card back, because if we pick a card and then we keep it out of the deck, the probability of drawing a red or a black card the next time is going to be changing with every card that we draw. Now, in example 2, we're going to illustrate how to do a simulation with cards. We have a soccer goalie who is named Kaylee, and she's claiming that she has the ability to save 40% of the shots on goal against her. So that's not a great percentage, but maybe nobody else on the team is able to play goalie, and she's the best one that they have. But then Kaylee has a game where she saves 7 out of 8 shots on goal. So this is a great game for her. And we want to know, is this just a situation of random chance where she just happened to have a really good game on this particular night? Or was she maybe not being honest with us about her ability to save only being 40%? So we want to conduct a simulation to see how likely it is that she is able to save 7 of 8 shots on goal if she's really only a 40% shooter. Now, we're going to use cards in this case. We're not going to use the entire deck, however. What we're going to do is we're going to take out 10 cards, and we want to choose 4 red cards and 6 black cards. And the reason we're using 4 and 6 is because 4 out of 10 is 40%, and 6 out of 10 is 60%. And that will kind of imitate the probability of success and failure in this situation. So we're going to say that choosing a red card represents a save for Kaylee, and choosing a black card represents a score on her. And this is a situation where we could not use a coin toss, because coin tosses can only be used in situations where it's 50-50. Here we have to do 40-60. So if you have cards at home, you can go ahead and grab a deck of cards, pull out 4 red and 6 black, and you're going to shuffle them up really well. Now, again, remember, you have to replace the card before you draw. So for trial number 1, we're going to pull out 8 cards because there are 8 shots on goal. And let's suppose we shuffle and the first card we pull out is a red card. We'll mark that as a save for her. Put the card back in the deck, shuffle up again, pull out another card. Let's suppose she gets you pull out another red card, which is another save. Put it back in and shuffle. And then maybe the next few cards that you pull out are black. And then she gets another save. And then the last one is a black card, which means a score. So out of these 8, she had 3 saves out of the 8. Now you can repeat that a second time. And maybe the second time we get something that looks like this. And maybe you pulled out 5 red cards this time. So she had 5 saves. And then just like we did before, we're going to put those results on our dot plot. So we have 3 and 5. Notice this dot plot goes from 0 to 8 because they're attempting 8 shots on goal, and she could have anywhere from 0 to 8 saves. So our results were 3 saves on the first trial, 5 on the second. And if you were doing this with a class, everybody would put their results up there. And let's suppose that when we do that, we get something that looks like this. So again, you can pause the video and go ahead and copy that result. Now, if she's a 40% free throw shooter and somebody takes 8 shots on goal, 40% of 8 is 3.2. And she can't get 3.2 saves, but she can get close to that. So notice that we had quite a few results where she had 3 saves or 2 saves or 4 saves, because those are all results that are close to that 40% that we expected. However, when we get out further and further from that, those results happen less likely. For example, we only had 1 trial out of all 50 trials where she didn't get a single save out of 8, because that would be a lot lower than what we would expect if her ability really was 40%. What we're interested in, though, is how likely is it that she's going to be able to save 7 out of the 8 shots? And notice that as we get further and further up on this end of the graph, that result only happened on 1 trial. 7 out of 8 is quite a bit above her claimed ability, so that result would be surprising. That would make us think that her original claim of only being able to save 40% probably was not true. And then if she did even better than that, if she was able to save all 8 out of 8, we would definitely think that her claim was not true. So this time we're looking at how many results happened on this end of the graph, because that's going to be the most convincing evidence for us about her claim not being true. So again, we had 50 trials here completed by the class. And when we want to look at the probability that she would save 7 out of 8 shots on goal or more, here we're counting up the dots that were at 7 or better. And notice we only had 1 dot, 1 trial out of the 50 that was at that result. So 1 out of 50 is only 2% of the time. It's extremely unlikely to happen. Therefore, we would say, because it's unlikely that she made the 7 of the 8 saves just by random chance, her ability is probably higher than the 40% that she claimed. Please do homework 1.4 in your assignment packet.